Welcome. Hi, welcome to the past question clinic. Okay. Hi, welcome to this episode of the past question clinic. In this video, we'll be talking about chemical combinations. In our if you have not checked out our last episode, in our last episode we talk about separating techniques. You can check under this channel. You are going to find the video. In this video, we are going to be talking about chemical combinations, and we are going to be treating all questions related to chemical combinations. Let's dive in together. Okay, what are the objectives of this video? By the end of this video, you should be able to understand and apply the laws of what? The laws of chemical combination. That is the law that binds the what? The relationship between two or more chemical substances. You should be able to understand and apply them whenever you need them. You should be able to apply the what? The mole concept in solving what? In solving problem related to chemical reactions. And you should be able to develop what? Critical thinking skills. Through the what? Through the 50 questions we are going to practice together. And you should be able to apply the what? The method to solve practical problems, especially when they pop up in your what? In your examinations and in life generally. So let's quick a quick review. What do we mean by chemical combination? Yes, I'm asking you, what do you understand by the word chemical combination? Okay, I can see you are trying to say something. Probably, okay, let's check. Probably you are right. Chemical combination explains what? How atoms are joined together to form what? To form a new substance defined by their what? By their valency, in order to achieve what? In order to achieve the stable electron configuration. That is what? Two atoms, they are going to what? They are going to combine together. Let's say sodium now is combining with what? With chlorine. They are combining for a single reason, in order to achieve what? Stable electronic configuration. As you all know, atoms like to be in what? In duplet, or what? Or octet state. So these are what? This is the stable state they used to run after. So the reason why they undergo what? They undergo chemical combination is to what? Is to achieve one of these two. Is to achieve one of these two, so that they can have what? A stable electronic configuration. So we have a number of laws of chemical combination. We have the law of definite proportion. That is saying that what? Well, irrespective of the source of a what? Of a particular chemical compound, the proportion of the what? Of the atom that make the compound will still be what? Will still be the same. Whether I get my own water from Africa or you get your own water from India, if you check the water is still going to have what? Two molecules of what? Two molecules of iron. It's going to have two atoms of hydrogen and one what? One atom of oxygen. Why the law of multiple proportion? The law of multiple proportion states that what? When two elements combine to form more than one compound, then the mass of what? The mass of one of those elements that combine with the fixed mass of the other, they will always be in what? They will always be in simple ratio. This one is talking about when two substances are combining to form more than what? More than one product. While the conservation of matter says that what? Matter can never be produced nor destroyed, but can be transformed from what? From one form to another. It can also be stated that what? The total mass before a chemical reaction must also be what? Must be constant in a what? In a closed system. That is what? The total mass you have before the reaction must also be equal to the what? The quantity of mass you are going to have after the what? After the reaction. And we also have what? Gay-Lussac's law of what? Of combining volume. that state that what? When gases react, they do so in volume that are in simple ratio to each other and to the product when what? When gaseous. And we have what? Avogadro's law that state that what? Equal volume of all the gases contains what? Contains equal numbers of molecules. So all these laws, we are going to be applying them when we are going to what? When we get to the question. So why is chemical combination important? So you can tell me, why do you think chemical combination is what? Is important? I'm listening. Okay, you can tell me that in the comment section. I would like to see what you have. The number one reason why chemical combination is important is the what? Is the reason why what? Atoms are actually participating in what? In chemical combination in the first place. To achieve what? To achieve stability. To achieve what? To achieve stability. It helps atoms to what? To achieve stability. That's the first important. Another important is what? The formation of what? The formation of new substances. Without chemical reaction, we cannot have something like salts. Like chemical combination is the basis of what? Of the formation of all matters that we have. Because a particular element is going to react with another to form another element, and that will still form another to what? To form another one. They will still react with another one to form another one. So it leads to what? The formation of substance. And also, it is the basis of life, because most life activities, digestion, stuff like that, they are what? They are all forms of chemical combination in one way or the other. Let's continue. So now, we have our first question here. The first question is saying that the ratio of the number of molecules, the ratio of the number of molecules in 2 grams of hydrogen to that of 16 grams of oxygen is dash. The first thing we need to know is what? What do we mean by what? By number of molecules. The number of molecules of a substance present in 1 mole of it is the same thing as what? As the Avogadro's what? Avogadro's constant. That is 6.02 multiplied by 10 raised to power what? Raised to power 23. That's the what? That's the number of molecules in a mole of a what? Of a substance. And we all know that what? Hydrogen and oxygen, they are both what? They are both diatomic gases. The mass of 1 mole of hydrogen will be what? Will be 2 grams, right? Because it is a diatomic gas. That is 2 times 1, right? And the mass of this one will be what? 32 grams. You know, an atom of oxygen is 16, but we're having 2 of it in this what? In a mole of oxygen gas. That is 32. That is what they are telling us here is that what? We have a mole of hydrogen gas and what? Half mole of what? Of oxygen gas. So what will now be the what? What will be the ratio of their what? Of their number of molecules? Since we know that what? A mole is going to contain this particular number. A mole is going to contain this particular number. Definitely, this 2 grams of hydrogen is going to contain what? 6.02 times 10 raised to power 23. While the 16 grams of oxygen, which is half of the mole, is going to contain half of this number. So the ratio will be what? 1 ratio what? 1 ratio 1 over 2. Right? 1 for 1 mole of what? Of hydrogen. 1 over 2 for the half mole of what? Of oxygen. And if we do this, we are going to get what? We are going to have 2 ratio what? 2 ratio 1. How do we get it to be 2 ratio 1? Ratio is like division, right? So we are going to have 1 divided by what? 1 over 2. So this division is going to change to multiplication, right? It will change to what? 2 over 1. And that will give us what? That will give us 2. And 2 is the same thing as what? 2 is the same thing as writing 2 over 1. Because any number divided by 2 is what? Is still, any number divided by 1 is still 1. So that way we are going to ascertain that what our answer for this particular question is what? Option A, 2:1. So the balance equation for the reaction between tetraosulfate 6 acid, that is H2SO4, and aluminium hydrate AlOH3 to give water and sodium and aluminium tetraosulfate 6 is dash. So they're asking us to balance what? Chemical equation here. Balancing of a chemical equation, what does it mean? That what? We must have the same quantity of atom on the reactant side and on the product side. So let's check. Here we have 2 hydrogen, another 3 hydrogen here, making 5. But on this side we are having 4. Therefore this equation is wrong. We don't need to bother ourselves. Here we have HSO4. HSO4 is not the same thing as H2SO4. So this one is also what? It's also wrong. Here we have AlH3 plus 6HO plus, we are adding, the question said that we should add what? H2SO4. So this one too is also what? It's also wrong. And the formula of what? Aluminum hydroxide is not AlH3. It is Al into bracket OH3. So here we have H2SO4 plus AlOH3. Yes, the reactant are correct. Let's check the product. Let's check if they are balanced. We have 6 hydrogen here plus another set of 6 hydrogen here, because these 2 times these 3 hydrogen have been making 12. So we have 12 on the product. Hydrogen is balanced. Let's check the oxygen. We have 4 oxygen here, multiplied by these 3, that's 12. Plus these 6 oxygen that are here, making what? 18. Let's check. We have 6 oxygens here, and we have another 12 here. Oxygen is also balanced. So we have sulfur. We have 3 sulfur here, and we have 3 sulfur here. Sulfur is also balanced. We have 2 aluminiums here, and we have 2 aluminiums here. Aluminium is also balanced. So the correct answer for this question will be what? Option D. Okay, next question is saying that an organic compound contains 72% carbon, 12% hydrogen, 16% by oxygen, of oxygen by mass. The empirical formula of the compound is dash. This particular question is under what? It's under empirical formula. So let's quickly solve it and let's see what we have. We have our carbon, we have our hydrogen, and we have our what? Our oxygen. Carbon is 72, hydrogen is 12, and oxygen is 16. So we are going to divide this carbon by what? By the atomic mass of carbon, that is 12. This by what? By 1. And this by what? By 16. Right? 16 divided by 16 will give us 1. This will give us 12. This will give us 12. And 72 over 12 will give us what? 72 divided by 12 will give us what? 6. That's 6. So that is telling us that what? The empirical formula will be what? C6 H what? H12 O what? And 1 oxygen, because O1. So let's see which one is correct. We have 6 H12 O. I think this is our answer. This is our what? This is our answer. We don't need to disturb ourselves. we have given the molar mass of iron 3 oxide and sulfur 4 oxide are 160 and 60 respectively. How many mole of iron 3 oxide will be contained in 1 gram of the compound? In 1 kilogram of the compound. Okay. They are asking us for what? For the number of mole. So we need to what? We need to recall what is the formula for the what? For the number of mole. That's the first thing we need to do, because the question is asking us what? How many mole? So we need to recall the formula for what? For the number of mole. Number of mole is equals to what? Is equals to the mass. The mass over what? Over the molar mass, right? Now our mass now is in kilogram, so we need to move it to what? We need to move it to gram. Is in kg. 1 kg to gram will be what? That is how many gram? Yes, you are right. That is 1000. That is 1000 grams. So the mass now is what? Will be 1000, because that's the mass they give us. But the question has already told us the what? The molar mass of what? Iron, which is what? 160. 100 and what? 160. So that will give us what? That will give us 1000 divided by 160. 0 will cancel 0, right? 2 here will give us 50. To give us 50 over 8, right? And that will give us 25 over 4, right? And 25 over 4 will give us what? CISO number 1 over 4, which is the same thing as what? 6.25. That's that. The number of atoms of chlorine present in 5.8 gram of sodium chloride is dash. So this particular question is asking for the what? The number of atoms of chlorine. So the first thing we need to know is that in a mole of chlorine, and in a mole of sodium chloride, in a mole of what? In a mole of sodium chloride, what is the number of atoms that we are going to see there? What is the number of atoms of chlorine that we are going to see there? It will be what? 6.02 multiplied by what? 10 raised to power multiplied by 10 raised to power 20 multiplied by 10 raised to power 23. Why? Because what? In the compound of sodium chloride, it has just what? 1 sodium and what? 1 chlorine. So in the mole of what? Sodium chloride, we are going to be having what? An Avogadro's number of what? Of sodium atoms, and that of what? Of chlorine atom too. So now we now have to what? Calculate the number of mole that we now have here. We already know what we are going to find in 1 mole. Let's calculate the number of mole that we have here. So the first thing is to find the what? Find the molar mass of sodium chloride. The molar mass of sodium chloride will be what? The molar mass of sodium chloride. It will be what? 23 plus 35.5, right? And that will give us what? I think that should give us, that's 58. 58.5. Yes, that should give us 58.5. So now we have 58.5 as the what? As the mass, as the molar mass, and the number of mole we have here is what? 5.8. So we are going to do what? The number of mole, the mass we have here is 5.8. So the number of mole will be what? Mass over molar mass again. Using mass over molar mass, what are we going to have? 5.8 divided by what? 58.5. And that will give us what? That should give us 0.1, right? That will give us what? 0.1. So since 1 mole of NaCl contains what? 6.02 times 10 raised to the power minus 23 mole atoms of what? Atoms of chlorine. Definitely 0.1 mole of NaCl is going to contain what? This particular number multiplied by what? Multiplied by 0.1. Multiplied by 0.1. And if you multiply it using standard form, 0.1 is going to reduce this particular 23 by 1, making it to bringing it back to what? To 22. And your answer will be what? 6.02 times 10 raised to the power what? Times 10 raised to the power 22. So the question is saying that what are the values of x, y, and z respectively in this equation? We have this, and we are asked to balance this equation. But looking through the option, we are saying that there is no 1 at all. So we should start with what? With 2. So let's put our x to be 2. If copper is 2 here, let's put our x to be 2. And we'll put 2 here too. So, you know, this is the proportionality sign. So now we have how many nitrogens on this product side? That this is 4, making 5 here, right? But we have just 1 nitrogen here. So let's put 5 here. Let's see. If you put 5 here, nitrogen is balanced, but hydrogen is not balanced. We have 1 hydrogen here, 5 hydrogens here. We have how many hydrogens here now? We have 2. So we can put 5 over 2 here. We can put 5 over 2. So it remains the oxygen. Here we have 15 oxygens. Here we already have 12. Here we have another 5, making okay. The next question is saying that the formula of the compound formed in a reaction between a trivalent metal. A metal that is trivalent means that what? It has 3 electrons in its what? In its outermost shell, and it has given out what? Everything. Like aluminium. And a tetravalent non-metal. A tetravalent non-metal means what? It has what? 4 electrons in its what? In its outermost shell. That is having 4. We are not saying what is the compound that is formed. To get the compound, you just have to what? Transpose this what? This superscript to the subscript of the other, and this superscript to the what? To the subscript of the other. So we are going to have what? M4 X 3. So which one looks like that? Okay, I think we can see that as option C. The next question is saying that how many mole of HCl will be required to react with what? 1 gram of commercial tetraoxocarbonate 4. . 1 gram of commercial tetraoxocarbonate 4. 1 gram of commercial tetraoxocarbonate 4 . 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 1 gram of commercial of calcium chloride. Of calcium. So the question is saying that HCl is reacting with what? With calcium. Is reacting with calcium triiosocarbonate 3. This will give us what? It will give us calcium chloride. To give us calcium. To give us calcium chloride plus what? Plus H2O. Plus H2O. Plus what? Plus CO2. Right? So, which one are we considering? How many moles of HCl will be required to react with what? With 1.0 gram of calcium chloride. No, I think there's a mistake with this question. The question should be 1.0 kilogram of calcium chloride. Yes. So the molar mass of calcium chloride of CaCO3 is what? 40 plus 12 plus 48. That's 100, right? So the molar mass of this is 100. The molar mass of this is 100. And that 100 gram requires what? 1 mole. That is telling us that what? 1 mole of HCl requires what? Requires 100 gram. 100 gram of what? Requires 100 grams. 100 grams of CaCO3. Right? So X mole, that is the mole we are looking for, we now require what? The mass that we are given. That is what? 1000 gram. Right? 1 kg is 1000 gram. Of what? Of calcium triiosocarbonate. So on cross multiplying, you are going to have your X. You are going to have your X to be equals to what? 1000 multiplied by what? Multiplied by 1. Everything divided by what? Everything divided by 100. Everything divided by 1. Okay, let's try to clean this side. So we are going to have our X to be what? One thousand divided by 100, because 1000 times 1 is still 1000. So This will cancel this, and the answer will be what? 10. The answer will be 10 mole of what? HCl. So the next question is saying that what mass of water will be produced when 4.0 gram of hydrogen react with what? Excess oxygen. What mass of water will be produced? Whenever you see questions like this, the first thing you must do is what? Is to write the equation of reaction. The first thing you should do is to write the what? Write the equation of reaction. So hydrogen gas, that is H2, is reacting with what? With oxygen gas to give us what? To give us H2O. To give us H2O. So the equation is not balanced yet. We put 2 here, then we put another 2 here. Right? The equation is balanced now. So they are saying 4 gram of hydrogen gas will react with what? Excess oxygen to give us how many mass of water? So from what I have here is this 4 gram of hydrogen gas is the same thing as what? 2 moles of hydrogen. Abi? It's the same thing as the 2 moles of what? Hydrogen. Definitely it's going to give us what? 2 moles of what? 2 moles of water, right? And we already know that what? 1 mole of water. We already know that 1 mole of water is 18 grams. So definitely the 2 moles will be what? 30. It will be what? 36 grams. So you don't even need to disturb yourself at all. The answer will be what? Option what? Option A. So the next question is saying that which of the following gases contain the least number of atoms at STP? As I've said earlier, according to Avogadro's law, the higher the number of moles, the higher the what? The quantity of atoms that it is going to what? It is going to contain, right? So we have 4 moles of chlorine, 3 moles of ozone, 1 mole of butane, 7 moles of what? Argon. Definitely 7 moles of argon is what? Is the one with highest number of moles. Therefore it will be the what? It will be the one that will contain the what? The highest number of atoms. No, it's the one that will contain the highest number of atoms. But the one that will contain the least number, please don't make the mistake. They are asking for the least number, not the highest. The one that will contain the least number of atoms will be what? Will be butane. Because it is the one with 1 mole. So we have what? A compound contains 31.91 gram of percentage of potassium, 28.93, and the rest are oxygen. What is the chemical formula of the particular compound? The first thing we need to know is what? What is the percentage of what? Oxygen. But since we know that what? We have just three elements in the what? In the particular compound. Percentage of oxygen. The percentage of oxygen can be gotten by doing what? 100 minus what? The sum of the other 2 percentage. Since there are just 3 elements that are there, definitely if we do this, it will give us the what? The percentage for the what? For the third one. So if we do this, the percentage of oxygen is going to give you what? So we have 31.91 plus 28.93. So that will give you 68.84. If you minus it from 100, that will give you 39.16. 39.16. That will give you 39.16. So we can go ahead and try to calculate. You can go ahead and try to calculate the particular element now. At the particular empirical formula, we have chlorine and we have oxygen. So the first one is 31.91. The second one is 28.993, and the third one is what? 39.16. So we are going to be dividing by the what? By the atomic mass. So this one will be divided by what? 39. This one will be divided by what? 35. 35.5. And this one will be divided by what? By 16, since it is oxygen. This one will be divided by 16. So 39.9 divided by 16 will give us what? This will give us 2.45. 2.45. Why the one for 28.93 divided by 35.5? That will give us what? 0.814. 0.815. And this last one, 31.9 divided by 39, that will give us 0.817. 0.817. So if you approximate this is approximately 1, this is approximately 2, and this is approximately what? 3. So we have what? 1, 1, 3. That is what? KCl O3. So that will be the answer. Option what? Option A. Okay, the formula NH3 for ammonia is regarded as the what? General formula, no. Structural formula, no. Molecular formula, empirical formula. So the formula NH3 of ammonia is regarded as what? It's not the general formula because this is not an ion. This is not like an hydrocarbon that has general family formula, and it's not the structural formula. It is what? It is the molecular formula because that's the actual what? Actual number of the relationship between what? Between the atoms that are what? That are present in what? In ammonia. Ammonia has just what? Just a nitrogen for every what? For every 3 hydrogens that it what? That it possesses. So the next question is saying that the postulate of Dalton's atomic theory that still holds still is dash. So Dalton's atomic theory is one of the theories that was first postulated for the atom, right? It states that atom is the smallest indivisible particle of a substance, and some other laws that it states also. But due to nuclear chemistry, we have been able to see that what? Atom still possess what? Some other particles. That atom itself is not the what? It's not the indivisible particles. So this law is not holding again. The particles of the same element are alike. Isotopes has disproved this. Elements are made up of small indivisible particles is the same thing as option B, so it is wrong. So the only one that is still in existence is the what? Is option A. The only one that is still in existence that still hold is the what? Is the option A. So the next one is what? What is the percentage by mass of nitrogen in this particular compound? Okay. The first thing we need to do is to calculate the what? The molar mass of this what? Of this compound first. After which we are now going to take the what? The percentage. In this particular compound, we have 2 multiplied by this one. We have 2 nitrogens there. We are having 2 nitrogens plus 2 multiplied by this one. We have what? 8. We have 8 hydrogens. Then we have what? Just 1 sulfur. And we have 4 oxygens. We have 4 oxygens. So we are going to be having 2 into bracket 14 plus 8 into bracket 1 plus 32 plus 4 into bracket 16. So if you compute this properly, you should have 132. You should have 132. You should have 132. So to the percentage now. The percentage will now be what? 2 times 14 is 28. It will be 28 over 132. Everything multiplied by what? Everything multiplied by 100. And this will give us what? This should give us 21. This will give us 21.21. This should give us 21.21. But we discovered that what? None of the answers is there. Probably is an error from the computation during the computation process. So the answer should be what? 21.21%. So we have this. In this equation of reaction, we are asked to what? Look for the value of X. X is denoting our nitrogen. On this side, we have how many nitrogen? We have 8 nitrogens. But here, we already have 6. That is 2 of this one, 2. multiply by this nitrogen in the bracket, we have 2 nitrogen, multiply by this 3, we have 6. So it remains what? 2 nitrogen to balance up. Definitely this S is going to be what? This S is going to be 2. And the P, where is P? Oh, there's no P here. But since it is P and X is at the back, and they are saying respectively, definitely the answer will be what? This one carrying 2 as the what? As the second option. Okay, this particular question is saying that a compound contains 40% carbon, 6.7 hydrogen, and 53.3% oxygen. By mass, the molar mass of the compound is 180. Its molecular formula is dash. So, from this particular question, we need to first calculate the empirical formula. And from the empirical formula, we are going to get the what? The molecular formula. So, we have 40% of carbon, 40% of carbon, 6.7 and 53.3 oxygen. So we are dividing carbon by 12. We are dividing carbon by 12. We are dividing hydrogen by 1. Okay. This is carbon. This is hydrogen. And this is oxygen. So, and we are dividing oxygen by 16. So, we are dividing oxygen by 16. Dividing carbon by 12 will give us what? That's 3.33. 3.3. This will give us 6.7. Why this? This will also give us 3.33. 3.3. So dividing through by the smallest, which is 3.3. We divide this one also by 3.3. And this one also by 3.3. So we are going to have it to be what? 1 ratio 2 ratio 1. So that is CH2 O, right? CH2O. So that's that. For the what? For the so the mass number is what now? The empirical formula is CH2O, but we need to get the empirical formula is CH2O, but we need to get to what? The empirical mass. The empirical mass will now be 12 plus 2 plus 16, and that will give us what? That will give us 30. As we already know that what the molecular mass, the molecular formula, and the molecular mass is equals to what? Is equals to N into bracket what? Empirical mass. So So our N will now be what? Our N will be equals to the molecular mass over empirical mass. So that will give us what? 180 divided by what? 30, and that will give us what? That will give us 5. That will give us 5. So if that gives us 5, we can multiply this by 5 to give us the what? We can multiply this by 5 to give us the molecular formula. So we are going to have what? Oh, 180 over 6 is 6. Oh, so sorry about that. It is 6. This will give us 6, not 5. This will be 6. So we are going to have C6 H12 O6, which is option what? Which is our option C. So let's clean this. So now the next question is saying that a radioactive element of 4.9 gram of tetraoxophosic acid. If a radioactive element of 4.9 gram of tetraoxophosic acid, calculate the amount of copper 4 oxide that will react with it. That is, they are telling us that they are reacting copper oxide with what? They are reacting copper oxide with H2 H2SO4. So what would that give us? That will give us what? Copper sulfate plus what? H plus H2O. Copper sulfate plus H2O. So they are now, what are we considering? We are considering copper sulfate and what? We are considering copper sulfate and H2SO4. From this, from the equation of reaction, we know that what? 1 mole of copper sulfate of CuO of copper oxide we react with what? 1 mole of H2SO4. Right? So definitely 64 plus 32 gram of copper oxide will react with what? React with the molar mass of what? Of H2SO4, which is what? 98 gram. 98 gram of what? Of H2SO4. So we can use this relationship to look for what we need. We can use this relationship to look for what we actually need. Oh, this is meant to be 16 since we have just one oxygen there. This is 16. So we have 80 to give us 98, Abi. So they're asking us for what mass of copper oxide. So that will be X. We now give us what? S will give us 4.9. 4.9. So if you cross multiply here and you calculate for the value of X, that will be 80 multiplied by 4.9 divided by 98. And that will give us what? 4 grams, which is option what? Option B. That will give us 4 grams. Moving on. The next question is saying that how many moles of limestone will be required to produce 5.6 grams of what? Of calcium oxide. Calcium oxide is produced from the what? From the decomposition of CaCO3, which is reversed to as limestone here. So let's see what we have from the equation. The first thing in this kind of question is to write the what? Write the equation of reaction. The first thing is to write the equation of reaction, that is CaCO3 will give us what? CaO plus what? Plus CO2. So from here we can see that what? From here we can see that 1 mole of calcium carbonate is going to produce 1 mole of calcium oxide and 1 mole of CO2. So they're asking us for the number of mole of limestone that will produce what? 5.6 grams of this. So we need to first know the number of mole of this. So the molar mass of calcium oxide is what? Is 40 plus what? Is 40 plus 16, and that's what? That's 56. So the number of mole will now be what? Mass. The number of mole will be 5.6 all over what? All over 56, which is the what? Which is the molar mass. And that will give us what? That will give us 0.1 mole. Since from the equation of reaction, 1 mole of this is producing 1 mole of this, definitely 0.1 mole of this will be required to produce what? 0.1 mole of this. So we don't need to disturb ourselves. The answer will be what? Option C, 0.1. So what is the molecular mass of a compound whose empirical formula has a mass of 25.0? This question is not complete. Okay, the next question is saying that 2 ethane is reacting with oxygen to give us 4 CO2 and water. Okay, they're asking us for the what? For the mass of what? Carbon 4 oxide. That is what? They are comparing ethane and what? And CO2. Let's first calculate the molar mass of what? Of ethane. The molar mass of ethane will be what? 2 into bracket 12. 2 into bracket 12 plus 6 into bracket 1 for hydrogen, right? And that will give us what? That will give us 30. That will give us 30. So here now we have 2 moles of what? Of ethane. That will be what? 30 times 2, that is 60 grams. 60 grams of ethane will give us what? A mass of CO2 is 44 grams. A mole of CO2 is 44 grams, but we have 4 of it here now. So that will be what? 44. That will be 44. Multiply by what? Multiply by 4. And that will give us what? That will give us 176. 176. So I have 60 grams of ethane is producing what? 176 grams of carbon dioxide. Definitely 75 grams we produce what? We produce X, and we are going to cross multiply here. So X will be what? Our X will be equals to 75 multiplied by what? Multiplied by 176. Everything divided by what? Divided by 60. And that will give us what? That will give us. So the answer will be what? 220 grams. So moving on, the next question is saying that they are reacting what? Magnesium oxide with HCl to give magnesium chloride, water, and chlorine gas. We are asked to find value of X, Y, and Z. From this side, okay, this is the reactant and product. We have Cl2 here. We have another set of oxygen. Okay, we can quickly balance the oxygen since oxygen is only existing in water here. So we can put 2 here for oxygen. 2 here. So if we put 2 here, so our hydrogen will now be 4, right? So we can put 4 here. So we can then balance it up with what? With another 2 here. No. We have 2 chlorine here already, so we are going to put 1 here like that. We are putting 1 here. So if we put 1 here, now we have one manganese. We have 1 manganese and 1 manganese. 2 oxygens, 4 hydrogen, 2 chlorine here, another 2 chlorine here. It is balanced that way. So we have 4, 2, 1. So the answer will be option D. 4, 2, 1. Option D. So the next question is saying that 2 sodium react with what? React with water to form sodium hydroxide and hydrogen gas. From the above equation, calculate the mass of sodium hydroxide produced by what? 2.3 grams of what? Of sodium. So they are comparing what? The sodium melter and what? And this. So what we need to know is what? What is the mass of what? Of this from the equation of reaction. We have 2 sodium, that is what? 2 into bracket 23. So that will give us what? That will give us 46. So this one is also what? 2 moles of sodium hydroxide. So a mole of sodium hydroxide is what? 23 plus 16 plus 1. So everything will be what? 40 that way. But we have 2 moles. So it will be, everything will amount to what? To 80. Everything will amount to 80. So we can say 46 grams of what? Of sodium produce, of sodium produce 80 grams. Produce 80 grams of NaOH. So 2.3 grams of sodium will produce what like that? 2.3 grams will produce X, right? So we are going to cross multiply, then our X is going to be equals to, 2.3 multiplied by 80 over 46, and that will give us what? That will give us 4 grams. So our answer will be what? Option C. So they are telling us that an hydrocarbon X with a molar mass of what? 26 consists of what? 92.3% carbon by mass. The molecular formula of X is dash. So since hydrocarbon is usually made up of what? Carbon and hydrogen, definitely if the carbon is if the carbon is 92.3, the hydrogen will be what? 100 minus 92.3. So we have our H and we have our C. So this one will be what? 92.3 while this one will be what? 7.7. So we are going to be dividing this by 1 and we'll be dividing this by 12. So this will be 7.7. This also is 7.7. 7.7. So by the time we divide by the smallest, we are going to have the ratio to be what? 1:1, right? So the empirical formula is CH. Empirical formula is CH. So the empirical mass will be what, like that? That's 13. 12 plus 1, 13. So by the time you divide the molecular mass divided by the empirical mass, that will give you what? 2, which is the value of N. And by the time you multiply these two with this, it is going to give you what? C2H2, which is the what? Option A. And that's our answer. The next question is asking us to calculate the percentage by mass of nitrogen in calcium triosinitrate. The first thing is to write what? Is to write the chemical formula for what? Calcium. To write the chemical formula for calcium triosinitrate. NO3. 2. So now we have 2 atoms of nitrogen here. That will be what? 2 into bracket 14. Right? Everything divided by what? Everything divided by 40. Everything divided by 40 plus 2 into bracket 14 for the nitrogen plus, we have 3 oxygens there, that's 16 times 3, that's 48, plus 48. Then we close the bracket. So we are going to say that everything multiplied by what? Everything multiplied by everything multiplied by 100. And that will give us what? That will give us 28%, which is option what? Option C. So this particular question is meant to be 6.0 gram of magnesium. We are looking for the number of atom. Number of atom, the formula for number of atom is what? Is the number of mole multiplied by what? Multiplied by the Avogadro's constant. So we need to find the number of mole of what? In 6 gram. So we already know number of mole is what? Number of mole is mass over molar mass, that is 6 all over 24 multiplied by 6 0.02 multiplied by 10 raised to power 23. So our answer will be what? Our answer will be 1.51 exponential 23. This particular option. That will be the answer. So the next question is saying that a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. If the molar mass of the compound is 180, find the molecular formula. So the first thing is to find the what? I think this question was repeated. We have solved it before, so it is option C. We have solved it initially. The next question is saying that an organic compound contains 69% carbon, 13% hydrogen, and 17.7% oxygen. Calculate the empirical formula. We are going to use the same approach, right? Okay, since we are using the same approach and we have solved a number of empirical formula questions, can you try to solve this and tell me what your answer is? Or try to solve them. So you are going to let's check if you are right. We are going to have 69 all over 12 13.3 over 1 and 17.7 over 16. So this will give us what? 5.75, and this will give us 13.3 and the last one 17.7 divided by 16. That will give us 1.11. So by the time we divide by the smallest, 5.75 divided by the smallest, that will give us 5.19, and dividing this 13.3 this will give us 12 and this will give us 1. So approximately the answer should be what? C5 H12 O. So probably there's a mistake in the option. The answer is not there. So the next question is asking us to calculate the percentage of sulfur in sulfur 4 oxide. Sulfur is 32. And the molar mass of sulfur 4 oxide is what? 32 plus 32, that's 64. You know we have 2 oxygens there, that is 16 times 2. That's 32. 32 plus 32, that's 64. So this should give us what, 50%. If you calculate this should give you 50%, which is option what? Option C. So the molecular formula of a compound with empirical formula CH2 and vapor density 42 is dash. If you watch the first episode, I said the molar mass is what? Is equals to 2 multiplied by the what? 2 multiplied by the vapor density, which is 42 here. So the molar mass will be what now? That's 84. So to get the number of N now, we are going to divide this 84 by what? By the empirical mass, which is what? 12 plus 2, 14. That's 84 over 14. That's 6. So it's that 6 we are going to use to multiply this empirical formula. That 6 is H12. Option what? Option C. So the last question here is asking us to calculate the number of molecules in 8.8 grams of carbon dioxide. So we have done something like this before. The number of molecules will be what? The number of mole multiplied by the what? Avogadro's constant. So we have 8.8 over, what's the molar mass of carbon dioxide? That's CO2. That's 12 plus what? 12 plus 16 times 2. That's 44. That's 8.8 over 44 is what is going to give us the what? The number of mole. Then we are multiplying this by the what? We are multiplying this with the Avogadro's number, that is 6.02 times 10 raised to power what? Times 10 raised to power 23. So this will give us what? This will give us 1.2 exponential what? Exponential 23, which is option what? Option A. And with that, we have come to the end of this particular episode. Kindly check the comment section. You are going to see a pinned comment that will lead you to what? That will lead you to a quiz on this particular topic to test your understanding. With that, you'll be able to know whether you have got a solid foundation in this particular topic or not. Thank you for watching and thank you for staying to the end. See you in the next episode.